Hi, good day. I'd like to welcome you to Winning the Race with Your Foot on the Brake, or put another way, enabling secure infrastructure as code via policy as code. My name is Tim Clegg. I work with different teams here at Oracle, advising them around the design of secure, automated, scalable, and extensible cloud architectures. Today's topic is one that I'm really passionate about, and I hope that you find of interest as well. To set the stage, though, let's first look at some of the drivers that we're facing today in our world. So from the business landscape, we see different demands to increase certain things, such as the features and functionality that we're driving within our products, the ability to rapidly iterate and change, what we're doing and how we're doing, and be able to reflect those changes much faster. Now, of course, our security posture is of utmost importance, and so we need to be increasing our security posture overall, because the threats are not letting up. The baddies, they're constantly there and they're unrelenting. Now, with that, we couple with that the fact that we've got certain drivers, certain things that we need to be decreasing, things like our costs or our operating expenses, things like our time to value or time to market needs to be decreasing. And of course, for many of us, we have the overarching theme of managing our regulatory compliance. Now, a lot of these, if you notice, they're not really technology facets per se. They're business drivers, a lot of demands and a lot of variables there that are ever increasing and ever changing. So what do we do? Well, we could look to hire a superhero. Fact is, that's not really practical. They're not around, and even if they were, probably wouldn't fit within my budget. So turning to something more realistic, what do we do? Well, oftentimes we'll turn to things like DevOps, for good reason too. It offers us speed, agility, things like infrastructure as code, which is superb, right? It gives us the ability to be able to monitor and audit what is taking place within our environment, and all stitched together with some pretty phenomenal automation. Now, if we start to compare DevOps against the business demands, what do we get? What does it deliver? Well, if done properly, DevOps does help us deliver more features, more functionality, iterate faster, lowers our time to market or time to value. And again, if done right, we can see a decrease in our costs or our operating expenses. What it doesn't really help us address, though, natively is those threats, those baddies out there that are constantly trying to seek to get in. And of course, our security posture overall, it doesn't help too much. And that thing called regulatory compliance is so critical, largely really doesn't help. So what do? Natural inclination is to add on red tape, and lots of it. We take things that are absolutely critical, things like our review boards, and we tack on manual change review processes, people or teams that need to manually review and audit certain changes or what have you. We might build abstracted tooling or customized tooling or interfaces that interact with the different pieces, the different components in the environment. And then, of course, what is this? None of this sounds familiar, right, in your environment? Of course not. What's the result, though? Well, we see ourselves losing a lot of the agility that we might otherwise have gained through DevOps, because we experience vendor lock-in, or not vendor lock-in, but just lock into our abstracted proprietary interfaces. Long queues and wait times. The agility and the speed that we saw with DevOps, we start to see really decrease, and overall slowness in terms of our reactivity and our agility to be able to respond to those demands, simply because of all the manual steps and oversight. Of course, with this, because of all that manual oversight and management burden, our costs can go up as well. So we actually kind of move backwards when we start to tack on some of these different, try to address some of these gaps. What we've implemented Suckurity. Suckurity happens whenever we implement a new technology and then try to figure out how to secure it after the fact. Security as an afterthought rarely results in an optimal solution. When we take DevOps, we make DevOps sec. It rarely results in an optimal situation. Now, keep in mind, I'm not suggesting things like review boards are not necessary. They absolutely are. We need them for proper governance. What I am suggesting is that we need more automated tooling to help enforce those activities that are permitted or prohibited within the environment. Suckurity ends up feeling a little bit like being on the racetrack, just like this race car, with our pedal to the metal, lots of energy, lots of direction, and we're faced in the right direction. We're trying to do all the right things. We have the right equipment. We're at the right place at the right time, and we have all the right pieces, except we're just not going around the racetrack very fast. And it's very difficult and can be pretty frustrating. So the question in my mind is, how do we shift from Suckurity to security? At first, it might sound a little trivial, and it's simply shifting security to the left. Taking, instead of DevOps Sec, DevSecOps, integrating security as an integral facet of what we do and how we go about doing it. Instead of an afterthought, make it an integral component. Now, just take for a second, before we jump into the rest of this presentation, I want you to answer in your own mind some questions. Is securing your environment important? Do you need to audit your environment? Is security stifling your organization? Does any of this resonate? Do you need a way to be able to quickly iterate and decide, have go, no-go decisions for change requests? If you've answered yes to any of the above, then you should really consider policy as code, which is what we're going to shift into. Policy as code, also lovingly referred to as governance as code or PaC or PAC, goes above and beyond what we have in our traditional cloud environments. Things like identity and access management, or IAM, it's a foundational component, absolutely critical by all means within our cloud environment. However, it only covers the basics of what I'm allowed to create, not necessarily how I create it. IAM doesn't delve into the resource attributes of what I'm going to create, but rather those resources that I'm allowed to create. This is where PAC, or policy as code, shines. It goes above and beyond what IAM delivers, giving us the ability to look at granular resource attributes and make go or no-go decisions based on what attributes it observes. Policy as code is powerful in that it can be used as both a preventive control as well as a detective control, or a combination thereof. With policy as code, we can have an increased level of assurance, consistency, speed, and agility. A lot of those things that, as we started having manual solutions that we were tacking on, those can be addressed programmatically. It can help us scale, very efficiently, in that we write a policy one time and can validate against it many times programmatically. We can make changes very fast as possible, so long as no violations occur. And this is where, when we're talking about a race, the analogy of a race, this is where if we put policy as code in charge of our brake pedal, we can be very fast, very agile, and be able to go as fast as we can around the racetrack, enabling our teams to iterate, move very quickly, unless there's a policy violation. Something happens that's out of what's authorized or permitted, at which point policy as code can apply the brakes, slow us down, allow us to be able to course correct and come back to it, retry again. So long as we don't have a violation, we can move as fast as we're able to. So it's a very powerful paradigm shift in terms of how we go about it. Now, there are some different evaluation methods to be aware of. Some solutions, some policy as code solutions will evaluate the actual Terraform code or the HCL or HCL2 code, while others look at the JSON. Understanding this is important because the HCL code or the Terraform analysis is often tightly coupled to a given cloud platform or solution. It can also impose, because we're looking at the code itself, it can impose a higher level of rigidity on the code itself, which is a double-edged sword. It's both a blessing and a curse in that we have a higher level of standardization. However, we suffer a decreased level of agility and flexibility. Now, JSON solutions, on the other hand, much more agnostic, looking at just generalized JSON code, and they're actually looking, from a Terraform perspective, they'd be looking at what Terraform is looking to do, not the code in which how we went about telling Terraform to do that. So it allows for much more agility in terms of the type of code that we can generate from a Terraform perspective. Now, there are lots of different policy as code solutions. I'm going to pick on one just because it's kind of my go-to default standard solution, which is Open Policy Agent. It's open source. It's part of the Cloud Native Computing Foundation. It does validate the JSON, and it has a really powerful policy syntax as well as built-in unit testing framework that I really like. It is flexible in terms of how you can run it as well, either as a runtime, evaluate one time and then disappear, or stay around as a persistent web service and do many evaluations. Very flexible. Enough with the theory. Let's dive into more of a pipeline example. This is a high-level pipeline example in that we're looking at a user who submitted some Terraform code, committed that to a Git repo, which then kicks off a pipeline. That pipeline goes through, it lints the Terraform code, it authorizes the code. If authorization passes, it'll then go ahead and apply it, and the end. We have a happy ending. If authorization fails, however, it'll bounce it back to the user with meaningful errors. The user can course correct, retry again. Now, that sounds great, Tim, but let's look at how do we actually do that? What's happening under the hood? Here's the same workflow, but looked at in greater detail. So we have a user here who's submitting code. This code triggers a pipeline. That could be via a code committal to a specific branch or the master branch, could be via a pull request or a merge request. Either way, that pipeline is initiated. The pipeline then initializes Terraform and then validates the Terraform, essentially doing a lightweight linting of the code. Now, once that code is validated, assuming it works, assuming everything's good, no errors, it will then go ahead and output the plan, the Terraform plan, into a binary file. Now, we need to provide the state file in collaboration with that. From there, it then runs Terraform show, outputting a JSON of what Terraform intends to do. That JSON is then taken and merged with, or not merged, but provided with the Open Policy Agent policy, which is then sent to Open Policy Agent for an authorization. If it passes, we apply it. If it doesn't, it gets sent back to the user with meaningful error messages, and the user can retry. It's a very high-level perspective in terms of what a pipeline might look like and how, for instance, using Open Policy Agent, we can implement that. Now, some different things to be aware of and think about when you're implementing policy as code solutions. And some of these are kind of, well, yeah, they're kind of obvious, but it's worth mentioning. Definitely place your policy as code policies in a separate repo. You want to maintain tight control, follow security best practices, right? Minimum need to know, minimum level of access to those policies. Typically, it'll be a delegated team who creates and manages those policies, and then maybe read-only access to different pipeline accounts, service accounts from that are used with pipelines to be able to read those policies to be able to actually perform the authorization. One other aspect here around the policies themselves is consider integrating these into the maintenance and creation of these into your existing review processes. The reason for this is we want to minimize any level of inference or assumptions that might be made, anything that might get lost from the team that's actually providing approvals to the team that's actually writing the policies. If we can narrow that gap and have a team or individuals trusted who are a part of that process who can codify those approvals in a policy, that's the best way possible. It also keeps our policies in sync with our overall review board processes too, so that way everything's consistent at all times. Now, as far as the policies themselves, highly recommend you design them in a parameterized fashion. What this means is, you can see here in the example, taking our variables and providing variables that are out of the separate file from the logic itself. What happens is, for a given environment, we'll define the variables for a given environment that get combined with the policy logic, which make up or comprise the Pac policy as an overall solution. That policy then authorizes JSON files. The power is that the logic will very rarely change. Once it's built, it can pretty much stay and persist for some period of time until there's something fundamental that changes in terms of what or how we're going about evaluating. Those variables will change from one environment to the next, though. And because they're variables, really don't need to get mired down in a lot of complex logic, rather very specific things that are permitted or prohibited for a given environment. The other aspect here is just keep your policies, the pipelines themselves, out of control of users. What we don't want is the ability for a Terraform user or a Terraform administrator to be able to remove or circumvent our policy as code validation. So keep those out of band. Keep them separate from, out of control of the general Terraform admin user. So where do we go from here? Really, it comes down to innovating. The goal is to secure our pipelines, our infrastructure as code pipelines, enabling our teams to move faster while still maintaining a high level of assurance and security. That's the goal. Hopefully this has been of help. I want to thank you for attending. Hope you have a great rest of your day here at HashiCorp Digital. Thank you.